Hello, welcome to ce3372, Lesson 1, Part 3. And Part 3 is a simple photograph tour of some water systems in the context of water system design. So we'll go to the notes page. So I'm at the usual entry point, and I want to bring up Dr. May's chapter and have that available. And what he's done is he has a very nice history of water systems. And as I'm scrolling through, I want to see if there's stuff in the latter part of the history. Well, maybe not so much, but first few pages, he discusses the history of water systems, and the important part is to convey how old they are. Civilization as we know it is dependent on water systems. Let's go to the lesson notes, and I'm going to actually use the PowerPoint, which would be the PPTX, rather than the portable document format, because it'll produce a higher quality video. So I've already downloaded it, and we'll go ahead and open up the PowerPoint and start the lesson. So I call this a brief history of water systems, and it's an adaptation of a slideshow by a colleague, Dr. Robert Pitt, at the Department of Civil and Environmental Engineering, University of Alabama, Tuscaloosa. He's retired, but he's still an emeritus professor at the university. Emeritus just means an old guy who doesn't get paid, but he gets an office. So as we proceed through the history, what I want you to do is consider whether the photograph represents a water control, water use, or an environmental restoration system in the context of part 2 of this lesson. So here we go to current Greece, but the site of the Delphi Springs in Greece. And you can see you should be able to see a stone wall moving there where the cursor is going, curse you, Red Baron. And then back here must be where the spring comes out of the mountain. And this was the center of the universe in the Bronze Age. It was the Austin, Texas of Greece. And there was an oracle there at Delphi. And the oracle was like a somewhere in the priest phase of things, and you would go there before you would invade your neighbors and ask the oracle what the success would be, and the oracle says, "I don't know, but leave me some money." All cynicism aside, the oracle played an important role in culture in that time as an advisory authority. It's kind of ironic when you think of it, or maybe it's just a joke played on us by the software industry, that Oracle is a database software company. Delphi is a programming language, not quite operated by that company, but a lot of the graphical interfaces that you all experience are written in a scripting language called Delphi. And here's the modern springs in the same roughly the same location. And what's modern is there's a pipe coming out of the header here, and so the spring water is collected probably to the right of the figure. Probably comes down here into this header box, and then it drips out of a pipe, and people can go fill up their water jugs and enjoy ancient Greek water. And so the question in the context of what I suggested is, is this a water use system, a water control system, or environmental restoration? We can answer that by looking at the pictures. If it's environmental restoration, it's not doing a very good job because that mountainside is slowly falling away. It's water control system in the sense that they're controlling the water that comes out of those rocks and delivering it to the pipe where the woman in the right photo is bent over filling her water jug. Mostly it's a water use system. It's providing a way to use this apparently magical water in Delphi, Greece. Different part of Greece. Agora, Athens, Greece. And what these photographs show, particularly the middle one's probably the best in conveying what we're trying to see here, is you see this rectangular rock-lined channel, and then there's these flat slabs that cross the channel, providing the ability to walk over the channel when it's full of water. Same here, we have these slabs to walk over the storm drain channel. So when you're in your togas, getting your bottom of your togas wet is no fun, so they have these things to walk over. We move to modern times, and here's a photograph of a crossing. This is in the Houston area. And you can see, technologically speaking, there's not a whole lot of difference. We have these big flat rocks that we cross over the drainage channel with. Now, scale's quite a bit different because in ancient Greece, liquid rock hadn't been invented yet, and in modern times we have liquid rock, which we call concrete, that performs all the benefits of actual rock in that it gets hard and it cracks. And so technologically speaking, this bridge here and this bridge here are fundamentally identical. They're doing the same thing. And, they're separated by 2,000 years of history. So, water systems goes back quite a ways. Now the question, water use, water control, or environmental restoration? It should be fairly easy. This is a control system because we're controlling the stormwater in such a way that we can continue commerce whether it's there or not. And moving along, we have some other photographs. The middle photograph clearly is a toilet and a sink. Probably not unlike the apartment that you all rent right now. I imagine yours probably has more of a wall on it, and you may not have to actually walk upstairs to use the head, to have enough head for the wastewater to be carried away. To the right, we have an open sewer system. And again, I hope that you are not living in a community where these are common. This particular one is from Eastern Europe, early 80s. And then we go back to an ancient ruins, and we see this channel here where the cursor is moving. Unremarkable, rocks, channel. And then we look at these platforms here, and those are clearly keyhole cutouts that are not unlike the toilet seat in the middle photograph. So this is a wastewater collection system. Now back in the olden days, you would come and, pay to poop, and then the poop collector would collect the poop, and they would process it because it was a valuable resource, both as nutrients for growing plants, and actually urine was valuable because of the urea that's in it. It could be used to set dyes and color clothes. And so all the rich people there with their beautiful dyed clothing were wearing the pee of the peasants to keep the dye in their clothing. Sure, they didn't think of it that way. And they had to invent perfume because they all smell bad anyway. Actually, I don't know. I wasn't there. So here we get back again to the question, water use, water control, environmental restoration. Arguably, it's a water use and an environmental restoration system in the sense that we're collecting the wastewater and not really letting it go out willy-nilly, and that provides some environmental benefit. But generally, we're collecting it as a use opportunity. Moving on in the photograph, we now look at some ways to move water from one place to another, and that's done in a conduit, or for lack of better words, a pipe. And moving from left to right, here we have a stone pipe that would take water from a reservoir and deliver it to an end user, probably to a fountain, circa 2600 BC. Now, being made out of stone, a 20-foot section of this pipe was probably heavy and took half a lifetime to fabricate. So the stone pipe makers of Crete had very secure jobs in some sense. Well, Rhodes, which is in Greece, which is close to Crete, they didn't want to wait that long, so they invented a way of taking rings of clay and smushing them together, cooking them, and then you make clay pipe. Interestingly enough, there's probably not much stone pipe fabricated today, but clay pipe is still manufactured today. It's called vitrified clay pipe. Nowadays, it's a pretty specialized pipe, but it has some advantages with certain kinds of corrosive waters. It's a really good wastewater pipe. It takes a fairly high skill level to install the pipe, and it needs to be in very stable soil so it doesn't break. So clay pipe is still in use today, and probably modern clay pipe, the manufacturer is not a whole lot different than the ancient clay pipe. Moving along, in Rome, the Romans built their pipe out of bricks, so they built it in pieces, kind of the original peace pipe. And here's more of a elliptical shape. It may have been built elliptical, or maybe centuries of smushiness kind of changed its shape. Nevertheless, these pipes made out of brick, there's probably not much modern pipe that's fabricated out of brick, but there's recent, my lifetime, manhole shafts and some fairly large diameter shafts that are fabricated or at least lined on the interior with brick. So you can see relatively modern versions of this. In London, they explored the use of lead pipe. In fact, probably the origin of the word plumber is from dealing with plumbum, which is the either Greek or Roman name for lead, Latin name for lead. They made lead pipe, and this was used to deliver water in the medieval times to the wealthy, and it made them nuttier than a fruitcake or madder than a hatter. Hard to tell which. And they also used cast iron pipe. And these are not ancient anymore. These are in the 1000 to 1400 AD, and cast iron in 1840, actually to present. In Seattle, lead and metal and things like that were hard to come by, but one thing the Pacific Northwest had an abundance of was wood. So they would fabricate pipes out of wood. And some of these are probably still in use today. Also not intentional anymore, but there are probably some wood pipes that are still in service today. And this is one of those few times when they had to make a round hole in a square peg to make it work as a pipe. And they probably choose to do a round hole because it was easy to make a boring machine to do that. And so Elon Musk's boring company certainly wasn't the first. The Seattle Wooden Boring Company was probably the first. Wood pipe has a really peculiar advantage in that if you want to make a connection to the pipe, all you got to do is punch a hole through the wood, and that hole is called in you provide water through the hole, and then if you want to cap it off, you put a plug in it. The plug is called a bung, so you can guess what the hole gets called. Water use, water control, environmental restoration. Again, these are probably mostly water use applications. Next we get into the lifting of water, because water is usually down there and we're way up here, and so we need to move it from down there to up here. And that's generally done by a device called a pump. And so here's a photograph of a large centrifugal pump. And so the water enters in this pipe here. This hole here is called the pump eye. And then there's a spinny thing in there. Looks something like that, although a little bit more sophisticated and made out of metal. And it doesn't have the woman with her child and umbrella turning the spinny thing around. It's done by an electric motor. And the water is accelerated to the outer periphery of the circular housing and then exits through this line here. These pumps here to the right are called Archimedes screw pumps, and they're not much different than the black and white photograph in operational principle, this one that's being operated by two young men to lift water from a supply into an irrigation ditch. Difference again between this picture and this picture. So this is a one-person power pump. This is a two-person power pump. And these probably have 100 horsepower motors on them. So you switch from people to horses, and then you increase the scale. And then this distance that the cursor is moving back and forth is probably on the order of 50 or 60 feet for a lift of maybe 10 or 15 feet of vertical lift. So the electrically powered ones can lift water quite a bit higher than human powered ones. But the fundamental background technology isn't terribly different. It's turning rotary mechanical energy into a vertical lift. So these would be mostly water use systems as shown here, but this particular Archimedes pump system, that actually looks like a sewage treatment plant, but they're in common use in flood control systems. So a pump is both a water use device as well as a water control device. And then the last thing we do with water is we store it. And the missing photograph is a photograph of a half-liter plastic water bottle, which would totally fit the theme of these pictures. So here we have two rock tanks, if you will. The one on the left is a cistern, the one on the right is its brethren. And what these would do is they would collect rainwater and the tank would fill up. And the stairs are provided so you can walk down to where the water level is, grab your bucket, and walk back and take your water to where you need it. And then the plastic water bottle hadn't been invented in the 7th century BC. So instead what they had were ceramic storage jugs. And these ones here are pretty large, and they have this lip on it so that you can tie 2 sticks of wood on either side of it, and then you have your water boy. Imagine ancient Adam Sandlers on each side of it would pick the thing up and carry it to where you needed the water. So these water jugs, or even the cisterns, we move to modern time. A modern equivalent of these cisterns with the varying level ability to extract is depicted here. This is Lake Mead. It's Boulder Canyon Dam. It's also known as Hoover Dam, but its original name was Boulder Canyon Dam, and then the vacuum cleaner company bought the rights to it. These circular objects here are the intakes to the power plant and any drinking water supply that the dam is used for. Actually, no, not for drinking water. Drinking water intakes are quite a bit upstream of this photograph. As the water level goes up and down in the pool, the intakes have different inlets at different elevations. It plays the same role as the stairs here. This big hole here is the emergency overflow spillway, and there's another one here. And then this linear feature here and the one you can't see here are actually side flow weirs. So if it looks like the lake is getting too full of water, these weir gates can be dropped a little bit, and the water flows over here and then goes through the hole and comes squirting out down here. It was tested when it was first built, and once again 20 or 30 years later, and it was used once for real. There was once a real time when the emergency spillway is activated, and there was so much water passing through the system that it damaged the tunnels that had been dug under this rock. And while I didn't almost lose the dam, had it gone on a few more days, they may well have. Down here are turbines that are used to make electricity. So the water comes into these inlets, drops down to the powerhouse, and then they make electricity with it. And the head difference, so this pool elevation in this photograph down to the lower part of the river here on the downstream side, it's roughly a 700-foot elevation change. So they got a fair amount of operating head. Now looking at the storage jugs, the modern equivalent is first make them bigger, because bigger is better. We can either build them on the ground, so here's some ground level tanks, or we put them up in the air for two important reasons. The main hydraulic reason to put them up in the air is it gives that water energy by being elevated. But the far more important socio-economic reason is it gives a place to paint the name of our high school football team. And so that's my story on tanks. And so these are primary water use systems. Lake Mead here, you can argue, is as much a flood control system as it is a water use system. Its purpose to some extent is flood control, but it was really built prior to World War II, not in anticipation of World War II, but as a way to generate electricity. And it can be argued that Hoover Dam and Grand Coulee Dam in Washington State generated the electricity that was used to smelt the aluminum that was used to build the airplanes that bombed the Axis powers during World War II. So without these dams, there may have been a different outcome. Some notable big systems that are worth visiting on the internet are listed here. The Los Angeles Aqueduct, you have a homework assignment regarding that. The Central Valley Project, which is in the Central Valley of California. The Salt River Project, which is in Arizona. The Tennessee Valley Authority, which is in Tennessee and many other states. And then I think I have it correct, the Three Gorges Project, which is the largest dam on the planet, and it's in China. Now, I don't know if these URLs work, so I'm going to take them right now. Okay, so you can see a picture of Ronald Reagan holding government cheese, and learn about the Los Angeles Aqueduct. So that's a good URL. Let's check the Central Valley Project. So that one's broken. Salt River. Interesting. Wikipedia is not rendering on my computer right now. Let's go to Los Angeles Aqueduct real quick. Okay. Okay, Wikipedia All right, so that's alive. That's being annoying. We can also look at Las Vegas Water Authority, New York City Supply, and Paris and Berlin. And let me escape and see what I can find on Wikipedia. Since I have the URLs, we'll try it this way. Copy. Paste. Fire. Okay, New York is there. Copy. Paste. Central Valley project's there. Salt River. So these all look like good URLs. It's just not linking on my computer right now. So I will leave that for you all to read. These are ones that I selected as good examples of big systems. It's worth going to those Wikipedia pages and reading about each one. It won't take much time. If you're having trouble sleeping, it may accelerate that. And the Paris, France one and Berlin, Germany one are also pretty interesting. Berlin's a pretty interesting city in and of itself, in that it's largely located in a swamp. So there's a portion of their water system whose purpose in life is to take water out of the swamp so that you can have a city on top of it. And that's less true of the other places in the interesting system list. And that concludes Lesson 1, Part 3. So you've had a brief history of water systems, and we've seen photographs of pieces of systems that largely support the water use category of water systems, but to a lesser extent, water control. Nothing specific on environmental restoration, but tends to be a co-product or byproduct of water use systems on the wastewater side of the business. And so that concludes this lesson. Thank you.